Hey guys, Mr. Adele here. So this is going to be our last section that we have to talk about and related to arrangements of electrons. And then from here we're going to end up moving into bonding. So, periodic trends. And I realize this is a hard topic, so if you have questions, feel free to ask either today via Teams or tomorrow. So, our first periodic trend is going to be our atomic radius. So if we picture our atom as a spherical shape, our atomic radius, if I have two atoms bonded together, our atomic radius is going to be 1/2 the distance between the nuclei of two identical atoms. So picture oxygen gas. So I have two oxygen spheres bound together. So the half distance between the center of each of those oxygen nuclei is going to be my atomic radius for that oxygen. So for atomic radius, as I go down a group, we're going to see the size of my atomic radius increase due to us adding those extra electron shells. On the other hand, as we're looking at our period, which is our rho, it is going to decrease going from left to right across my period. And that's due to the fact that I'm going to have an increased positive charge. And what I mean by that is I'm going to have a stronger pull because I'm going to have less electrons shielding. And we're going to talk about the idea of shielding later on, so hopefully that'll make a little bit more sense. So, moving to our next slide. We've talked about ions, but we haven't really introduced it from a true book definition type of perspective. So an ion is any atom or group of bonded atoms that has a positive or negative charge. If I have a positively charged ion, it's called a cation, and this is due to it losing electrons. If I have a negatively charged ion, that's going to be called an anion, and that's due to my atom gaining electrons. So, shielding helps determine both atomic radius and ionic radius. It's a little bit more apparent that we need it for ionic radius. So anyways, we have Z effective, which is the effective number of protons interacting with my electrons. So my Z effective is going to be equal to Z, which is the number of protons in my nucleus, minus S, which is the number of core electrons. So those are electrons that aren't in my outside shell or my outside layer. So whenever we're talking about Z effective, so looking at carbon versus lithium. Lithium has 3 total protons. Lithium has 2 core electrons, which means lithium would have a Z effective of 1 plus. But if we look at carbon, carbon is element number 6, so carbon has 6 protons. But it also has 2 core electrons, which means my Z effective is going to be plus 4. So, with that being said, for my atomic radius, my protons are going to have a stronger pull on the electrons in my outside shell. So jumping back to ionic radius though, so we're going to see the same trends. So ionic radius is also going to increase going down the group due to the increasing number of electrons in the innermost electron shells. And that's because we're increasing the number of core electrons, which means we're effectively reducing the number of protons, or the number of protons exhibiting a pull on my outer electrons. So our cationic radius is going to decrease up across the period for metals due to relative increase in nuclear charge. Our anionic radius is going to decrease across the period due to electron repulsion, causing a high Z effective. So, in other words, I'm going to have so many electrons that they're going to force themselves away from each other, which is going to allow my protons to essentially have a more effective attack on each individual electron for anionic radius. So we see the same trend, but for different reasons in my metals versus my non-metals. Alright, so our next trend is called ionization energy, and it's essentially the energy required to remove one electron from a neutral atom of an element. So if I have element A and I give it energy, I am going to end up with an ionic form of A and an electron. So this is going to decrease going down our groups, and that's due to electron shielding of the outer electrons. My Z effective is going to be weaker, so it's going to be easier to remove that outside electron. So at the same time, we're going to see this increase across the period due to increasing nuclear charge. So I have a much stronger pull whenever we're going back to the example of lithium versus carbon. So I have a much stronger pull on that outside electron in my carbon than I do in my lithium, which means it's easier to lose that electron in my lithium. The same is going to hold true for any elements if you pick any elements in a period. It's also possible to have multiple ionization energies. So what this would be doing is I would take that 1+ charged ion and ripping another electron off by giving it energy to do that. We keep doing this successfully. It's going to get continually harder and harder and harder for each successive electron I remove, though. So our next trend is electron affinity, and this is the energy change that occurs when an electron is acquired by a neutral atom. So most atoms are going to give off energy whenever they Excuse me. Most atoms are going to give off energy or release energy whenever they gain an electron. So we could write this as a general formula. A plus electron gives me A minus plus energy. But that's not to be true for all atoms. Some are going to be forced to gain that electron, which means it's going to take energy to cause that electron to be taken by the atom. So in this case, I would have a general format of A plus E minus plus energy gives me A minus. So as a rule, electrons are added with greater difficulty going down a group because there's a smaller Z effective, which means it's harder to hold that electron in place. So it's going to decrease going down my group. It's also going to increase going across the period for the P block. And that has to do with our trying to balance out Z effective. Or how basically is I have a stronger Z effective, the easier it is going to be for that Z effective to grab new electrons. We do see an exception here at groups 14 and 15. Group 14 has a half-filled P shell, whereas group 15 does not, because it has 4 electrons in my P shell. So we should expect to see the electron affinity for group 14 to be higher than the electron affinity for group 15. So whenever we're talking about these ions and electrons being moved or held onto, etc., gained, we have a rule called the octet rule. The octet rule essentially says outer electron shells are going to consist of an S and a P orbital. Or sorry, an S shell and a P shell. So our outer electron shells want to have 8 total electrons, which is a full S shell and a full P shell. Or to rephrase that, it's going to be a full S orbital and 3 full P orbitals. So these outside electrons that we're talking about for our trends are what's called a valence electron, which is essentially an electron that we're able to lose, gain, or share in the formation of chemical compounds, which we're going to get to whenever we talk about bonding later on the weekend into next week. So our last trend is going to be what's called electronegativity, which is essentially the ability of an atom in a chemical compound to pull electrons from another atom in that compound. So my electronegativity is going to decrease going down the group, and it's going to increase across the period. Excuse me. So the increase across the period should be pretty obvious. My Z effective is higher, so I'm going to want to try to pull electrons to me to balance that out. So I'm going to try to pull electrons away from other atoms to do that and make that Z effective smaller, because that atom essentially wants to have a full octet shell, but 2, it wants to have a relatively weak Z effective. As for decreasing down the row, Z effective is going to be weaker, once again making it harder to hold on to electrons, which means I'm not going to have the ability to really pull electrons towards me the further I get down my group. Alright guys, so if you have any questions, feel free to ask. We're going to have a Schoology meeting during class time. There's also going to be an assignment where you guys are going to have to try to explain trends. We're going to look at that tomorrow. And then there's also going to be another assignment to go along with this, which means we will probably be starting bonding towards the second half of this week. If you guys... So, like I said, if you guys have any questions, feel free to ask. I'm always available via Teams or Schoology or whatever. So